I think to start off, I would ask each of you up here to identify him or herself as to what you were then and what you are now. You want to start, Nancy?
Thanks. Up here, sort of this representative, right? I work in part-time operator / consultant, and probably more appropriately also / house inspector. I'm still there. You can eliminate the first parameter of the data structure.
My name's Steve Fobbs. Well, I currently am the grad student at Carnegie Mellon University. Back then, we all went by the names of the programs. Back then, people would say, go up to me and say, hey, DET, how come such and such doesn't work? For example, I'm sitting next to one of the several people called BASIC. I've also worked on a Lisp system back then and a variety of other various things.
I'm Neil Wiedenhofer. I was a graduate student at Dartmouth back in those days. I worked mostly on the BASIC compiler. Now I'm a systems programmer for United Computing Systems. For time-sharing.
My name is John Machiki. My current job is to worry about things like editing the page and making sure the accounting system runs. In those days, I was a student and worked as part of the time-sharing system. In difference to what Steve Fobbs said, as I recall it, I was everybody there before you used to know our programs by the name people wrote them.
My name is Dave McGill. I'm currently a teacher of Transcendental Meditation and a systems analyst for Planning Research Corporation. And back in '64 to '68, I worked variously on the BASIC project on 635 and on some of the time sharing project on 635.
My name is Ron Martin, currently with the Cybernetics Corporation as Manager of Telecommunications Development. Been there for 5 years. Back in '63 through '67, I was a student at Dartmouth, and I worked together with Mike Bush in developing the first ANET 30 executive. After that, I worked on the MOLD system, which was a developmental time-sharing system, of historical interest only, and also on the first 635 time-sharing system, in both of the latter cases on the communications executive.
I'm Kevin O'Gorman. These days I run programming in BASIC and of BASIC for a small computer outfit in New York. And in those days, I guess I was ALGOL.
I'm Mike Bush. I'm presently in management at Computer Sciences Corporation. I've been involved extensively with CSC's Infonet time-sharing network, and more recently involved in facilities management for state and local government. Back then, I was involved in writing the first master executive for the DataNet 30, and perhaps John McGee's principal adversary.
My name is John Kemeny. In those days, I worked with Tom Kurtz, who was in charge of the time-sharing system overall, that wrote the first BASIC compiler. I won't mention my present job, but it's clearly not nearly as good as the one I had in those days.
Now I'm at the program. At the time, I sort of inherited the 235 executive after John graduated. Went away and 235 and then 600 section. I got out of Dartmouth in '67, so didn't really see the 600 doing all that it does now. Some ways I'd like to go back and, really get some hang on it.
Well, I'm Tom Kurtz, and looking around the panel here, I think that Nancy and I are the only ones who are still doing the same things we did 10 years ago.
My name's Sidney Marshall. I'm currently a scientist with the Xerox Corporation. And I started out on the LGB 30 committee I think I was the first high school student to start stealing time from college. And I worked on, I was not in at the original section of the 235 system. I wrote TSAP, whole system. Good part of the exec for the current system, which I suspect has now been chipped away by succeeding programmers.
Hi, my name is Greg Dobbs. I'm currently a research associate at MIT. Some of the other people that couldn't be here today, like myself, are not mathematicians. I'm in chemistry. That wasn't too uncommon at Kiewit for people from all types, pre-meds and whatever, to do systems programming. I inherited the editing systems for the 200 and in conjunction with Pete Nielsen, shepherded them through the mold system onto the 600. My name is Jerry Wiener. I'm a new product manager at Pitney Bowes. And I'm the first one in industry that ever believed what Kemeny and Kurtz said could be done. I was the GE project manager. My function was flying in spare parts when they burned them out. Although the DataNet 30 was standard off the shelf, it was standard off the shelf and it was 00 and one of 10 unique machines. We rebuilt it without telling it to people, things of that time.
My name is George Devitz, General Electric R&D Center in Schenectady, and my participation on the 265 was to build the background Fortran system, which enabled people with bigger jobs to work in the background. My name is George.
You're going to switch. My only comment is that this sounds just like the good old days. I'd like to start things off by asking a question. Does anybody here really remember what happened on May 1st, 1964?
I think you people in 5 years are missing the one crucial element that Dr. Piper has been using. I tried myself to find being in Thomas Kurtz's class in 1964, in spring of 1964, and we started out in that class using BASIC on cards on a GE 225 in the basement of College Hall. And then we moved from there to 3 terminals in the basement of College Hall, and Mr. Bush and Mr. McKeechee at the time just, I guess we used to call you Keechee. We had a very difficult time with him because every time we were trying to get our programs, he would follow the system. He saved I'm strictly a user.
Shill's in the audience.
Let me at least try to answer that, and I can't swear that this is true, but I think the goal we set ourselves was to have a program in BASIC work simultaneously on 2 terminals. And I think that's what happened early in the morning of May 1st, and it probably was adding 2 plus 2. And
if my recollection was right, I don't remember the specific incident, but it just had to be prime numbers by the sieve method.
Prime At any rate, there was a relatively simple program in BASIC where both the BASIC worked and time sharing worked, in that we got the right answer, the program to run on 2 terminals at the same time. Actually, you may think that's a very small achievement, but once we got to that point, things went terribly fast after that. I mean, from that to going to a larger number of terminals and having most of BASIC work really took much less time than the major breakthrough.
Comment on how fast things went. We went from phase 0 to phase 4 in 9 months.
Just like the federal government. I think since Tom is chairing this panel, I would like to make one remark about what really happened. The key event occurred really in the academic year 62-63. Serious planning started in the spring of 63, and a year and a half later, there was a multi-terminal system in operation. And those you see here had a very major role to play with it. But how it really started, I think, goes back earlier than that. Namely, the fact that Tom Kurtz had a ridiculous dream. He had the idea that it would be possible to come up with a computing system where every student at Dartmouth would have a chance how to learn computing. Furthermore, he had the dream to make a computing system available the way an OpenStack library is available. One of the earlier panelists talked about that, but that was a terribly radical idea as recently as 11 years ago. For most academic institutions, it's still an unheard of idea. And I think as we talk about some of the details, one should not forget the fact that Tom really had those two absolutely key ideas that revolutionized educational uses of computers. The only other thing I remember about those days was that it was very good that both he and I were quite ignorant about computing, because we did not know that what we were about to attempt to do was impossible.
John, didn't you invent a particular way of solving problems when they're solving disputes, when there were disputes or disagreements among the student programmers? Well, didn't you say once that they could solve the large problems, but you reserved the right to solve the small problems? I remember something like that. Am I the only one that remembers that?
Dartmouth was very selective in hiring computer operators at the time. I remember handing Professor Kemeny decks of cards to put through the card reader, and then everybody ran over to the printer to see if BASIC was doing what BASIC was supposed to be doing at the time. This was before the time-sharing system was running, but he was debugging and we were, I guess, helping him.
Does anybody remember the one-card wonders?
It's an in-card compile.
Yes, it was quite crucial, of course, because before you got time sharing going, you had to get into the system basically with cards, and we had a number of single card things, and it was a competition on how much you could make one single card do. Mike, do you remember some of them? I remember there were great competition on things everybody said you couldn't possibly get all on one card.
I think the winner of the contest was a program that produced one-card wonders.
Actually, that was the one-card wonder maker. Between that.
Well, since we're reminiscing, let me mention one thing about the early days of BASIC. We only had one big argument on BASIC. The idea sounded very attractive, but coming up with a brand new computer language when Fortran was clearly going to be the only language ever used in computers, many people argued it was a crazy thing to do, and that we might be leading our students down the wrong path in inventing a new language where, when they graduated from Dartmouth, it would not be usable in any other system except our own. I think 10 years later, it's safe to say we won that particular game. I'm trying to estimate, Tom. I'm trying to estimate how close we are to the billion jobs being run in BASIC, but just from the statistics we saw, about 50 million of them must have been run by now at Dartmouth College. And given all the other places they use, we probably can claim that more than a billion jobs have been run in BASIC all over the world.
Well, I claim at least 10,000 myself.
GE did a survey of all of its major programming managers, and the conclusion was that BASIC had absolutely nothing to offer that wasn't done better in Fortran. And I said, you missed the point completely. It's a simple system for the user.
Well, getting down to some more, some amusing things, I seem to remember some funny things like wastebasket fires in the basement of a most unfireproof building being one of the hazards. Does anybody remember wastebasket fires? I guess those people are not here. Won't know the answer.
I think I remember also one of our students that one time, only once, I saw actually put a cigarette into an ashtray. Unfortunately, the next thing he did was set a notebook on top of it.
It's interesting to see how much student assistance techniques have changed over the years. I remember when I first wrote my first system, time to bug it, I sit by the console typewriter and look at the lights. When something that looked like my program swapped in the memory, I get carriage return that finished off a dump to me and dumps all of memory on the printer.
see if I could figure out what's going on. That wasn't good enough. I went to the D30 and flipped the switch that prevented that jump to boot instruction from being loaded in the memory. I save in the memory, I hit manual and single step my program, see what it was doing. Much to the very upsetting to the people upstairs in the terminal room, but while I was single stepping their program, time sharing had definitely stopped. Nowadays, what? Yes. Nowadays, I use fancy debuggers with symbol tables supplied by assemblers, and multiple debugging. You can single step your program while everyone else runs. It's a real change.
Along this line, debugging the format statement processor for this Fortran system, I wrote a routine which did a trace by entering interrupt mode, printing out the contents of all the registers, setting an interrupt and exiting interrupt mode. And this spewed out paper for several hours before I found the error. But that was one of the nice things you could do about it. It did the interrupt after every instruction.
As I remember, the behavior you found was that you had to turn off the interrupt and all in an opener.
Maybe.
I really think that the memory that sticks in my mind is not things like fires in wastepaper baskets, but seeing Bush and McGeechee at the two machines. You see, one of the very big problems was I think it was the first attempt of trying to have two different computers working in parallel and cooperating with each other. And the two of them took this terribly personally. I mean, it wasn't John's machine and Mike's machine. It was John and Mike who were not responding. And they would stand at opposite ends of the room and yell at each other at the top of their voices. And how they became lifelong friends in spite of that is something I will never understand. I wish you would tell us a little bit about the experience of debugging that two-part executive.
I have a story about that. One of our long-lasting quarrels, I got so sick and tired, I said, well, I'm going to fix it. And so I put a couple of messages in 235 executive. One message said Bush did it. The other message said I did it. I figured the message that says I did it would never come out. So I went away, and next day, this particular thing happened. And I was very bad to see the message I did it.
In the early days of development, before the 235 exec was working, the Data 30 exec was checked out with a little dummy routine that just sat in the 235 and responded with the right responses without doing any of the computing or processing. And this was the basis for many of the arguments that ensued, because we were absolutely sure that the DataNet 30 couldn't possibly be wrong because it always responded right with the simulator. Of course, completely ignoring the fact that the simulator might be wrong. And I believe that was the fuel that convinced Mike that he was right, and of course John had his own reasons for thinking that he was.
I think our approach is reliability is sort of interesting too. I recall one time in the early days when we were developing the system, it didn't matter very much when we made changes because the new versions were not really that much better than the old, and they all had bugs. Well, after the system had been running for about 6 months, people started to count on this. It became a little harder to put in new versions of executive. So Mike and I developed this technique, appearing about 2 in the morning, putting in our new binary decks, taking the old decks and throwing them away. Just making sure that next day there was no way to back up. Unfortunately, we did this once when Professor Kemeny had a demonstration schedule.
Nobody's going to tell what happened.
I don't know. All I remember is getting up very early in the morning and driving kind of frantically from where we were staying that summer and trying to fix things. But I have no recollection of whether it ever worked again or not.
I have a little story I'd like to tell. There was always an immense feeling of power when you worked in the basement of College Hall. You knew those people were upstairs pounding away at the terminals, and you held their very life in your hands, essentially. Along the way, I had developed a little program which is well remembered, I'm sure, by anybody who was there. It was a program which generated random sentences, and the subject matter of the sentences was completely obscene. And the interesting thing was that it wasn't enough that we were amused by the program, But at one point, we even went and printed out reams of line printer paper to test out the first time-sharing compatible batch BASIC. And we used to drive down to the Polka Dot or the Four Aces, and we'd sit there going through these reams of paper and looking for something that was more than just random, that just, was considerably creative. And I remember the look on some of the waitresses' faces while we were doing that. We got kind of tired of that and found a new technique. We would sit at one of the control terminals of the system, change a few internal system pointers, and pawn our program off on an unsuspecting user. The only thing was, we didn't want to waste time to look at who it was, so we never knew who the victims were. And what would happen from the user's point of view is that they would be typing in their program to solve a differential equation or whatever, and finally they would be done, they would say run. Somewhere along the line, I had slipped them this other program in place of the one they were creating, and instead of the output they expected, they would get these streams of random sentences. This story has kind of an interesting kicker to it. Several years later, when we had the dedication ceremony for Kiewit, the new computation center, I remember that Dr. Kreider was sitting up on the stage, reminiscing at that point about some of his early experiences as a user. And I was in the audience with a couple of other people that remember the incident. And I remember he made some remark about how he sat down at his terminal and typed run and how all this stuff came out on his terminal. And he never knew who did it. And I don't know that until just now that he ever did know who did it. The cat's out of the bag.
I think that, people are cutting reliability of systems short. I got there in '65, so I'm not sure if I'm a real pioneer. When I got there 1 year later, September of '65, it was completely reliable. I mean, as far as I could see, they brought up experimental time sharing on Sunday, and no one could tell the difference that it was experimental. It seemed to work just as good as the regular days. We were one experimental session, just to let people know it was really experimental. We went into the character translation table to take the internal BCD and translate it to the teletype and switched the entries for the digits 2 and 3. Made the basic program for I equals 10 to 100 go 10, 11, 13, 12, 14, 15, 16, 17, 18, 19, 30, 31, 33, 32. Now, this is no problem to a systems program, but at least let the users know it was experimental time sharing. Because it really was, when I got there, extremely reliable. I was amazed. I had had some experience with CTSS at MIT. In reliability, it was much better. I was surprised it's just a small system with relatively poor hardware that was that reliable.
I remember one thing about that. If you didn't have the program already typed in, you had the problem of being creative and typing your lines to either avoid line numbers containing the digits 2 or 3, or to use them properly. And properly is not an easy concept in this case, because clearly if the end statement wound up being sorted before the end of the program, it wasn't going to run. And other such similar problems, you could have 4 statements after your next statements and so forth.
I should mention the first person to patch that program changed the translate table from 2 to 3 and then discovered he had no 2s to put into the system, put the other patch in.
No, that was a serious problem, but we did it by using a 3rd digit and an intermediate step.
And then there was the case where a slight modification of the program was made so that on March 15th, all output came out in Roman numerals.
Tom, I think I have a sequel to your story. One of our very able student programmers who graduated a couple of years ago finished the new version of BASIC, and he finished it sort of about the time he graduated, and lo and behold, 9 months after this gentleman left on March 15th, everything started appearing in Roman numerals.
Maybe it was the same programmer.
I don't think so, because he wasn't there.
But the reliability of the system, I remember we used to, I think Nancy left. When did you leave, Nancy? But
at that point, we started, I was the only operator, and I was there during the day. And then all our student programmers were assigned hours during the evening when the system was up, when they were the official operator. And I think from looking at this crew, you can imagine, now 10 years ago, really how often they showed up when they were supposed to do this. Luckily, the system was sufficiently reliable, and there were pretty quickly enough knowledgeable people on campus that if you happened to be using the system and it stopped, well, there was one very common symptom, and everybody knew what it was. When you went down to the basement of College Hall, unlocked the door with a nail file or your ID card, whatever you happen to have handy, walked over to the disk, pushed one button, everything started up, and you went home. And the system sort of ran that way, eventually completely unattended over the weekends, and pretty much generally unattended.
Yeah, I remember one time, I got a call at night. It was actually quite late at night. And for some reason, the system, which normally would run and run and run and run, it went down on one of those rare occasions and needed somebody to come in and push that little red button on the disk. But the person who called didn't live in Hanover. As a matter of fact, he lived in Pittsburgh, Pennsylvania. And he called me because I was the only one he knew phone number of, and said the system went down. And I said, Jerry, do you know what time it is? It's 3 a.m. in the morning. I'll be damned if I'm going to get up and go down and push that button.
Speaking of phone calls and things, one of probably the earliest program in the program library was football. And a lot of us here know who wrote it. And I remember one night, we'd been apparently having some problem somewhere along the line. And I got a phone call at home one night to tell me, in absolute panic, football has been clobbered in the library. And I live a good half hour away from Dartmouth, and I really wasn't about to jump in the car and trot in to reload it from cards, or paper tape was probably what we had for backup at that point. So I just sort of sleepily said, well, I'll put it back in the morning. But what did you really expect me to do?
We were probably trying to recruit a new football coach, Nancy, and it was terribly important. I don't remember who wrote it, but I do remember when that program was written. It was written on a Sunday. Those were the good days when time-sharing still ran on Sundays. It was written on Sunday after a certain Dartmouth-Princeton game in 1965 when Dartmouth won the Lambert Trophy. It's sort of a commemorative program.
There was also an earlier program for baseball. It was well remembered. I was just wondering, would somebody like to tell the Jolly Green Giants story?
Yes, I was wondering about that too. That should be told.
In the summer of '66, I got hired by the GE Research Lab to make a Chinese copy of the 265 software and install it down there. And at that time, GE itself had written a Fortran compiler to run on the 265 system for use with the commercial time-sharing service. But the time-sharing service people would not let the research lab have a copy of the program. So when I got the 265 installed and the software running at the lab, one afternoon I didn't have anything to do. So I said, well, I'll try this Fortran. So got out a manual, tried it. Aha! But this line in the beginning of your program, you can print the object code. So printing the object code, pretty soon I discovered that, yeah, the right sequence instructions, you're into an array. At that point, I could write a disk read routine. So I wrote a disk read routine which read the Fortran compiler off the disk, encoded it in a suitable form for transmission by back to the teletype, and sat and typed it out. It took about 3 teletypes for 8 hours to type the thing out. And then we read it into our 265, converted it to a deck, and it was running it quite normally. We had a program which we would run on the commercial time-sharing system once a week to discover whether there are any patches put in the program, so we could put them in too. And this went on for, we were merrily running this thing for about 2 months when my boss's boss goes to the time-sharing headquarters in Phoenix at that time and says, 265 is up and running. We even have Fortran. I gave it to you. Why did you steal it? You know, who's the leak? Very simple. our people wrote a Fortran program to copy it off the disk. Don't believe it. Impossible. Can't be done. So he came back a few days later and related this story. So we said, well, sure, it's quite possible. We can read the disk, we can write the disk. So we proceeded to write a patch to the 235 exec onto the local time-sharing service in Schenectady, which would type out a message once a minute. Denny VD Victi. And we waited half an hour and no response. So we decided, well, we'll try New York City IPC. Message was, if you don't believe this, call Dan Scott at dial.com. Waited another half an hour, no response. So we decided we'll try Strike in Phoenix. So we put one in there which said, Jolly Green Giant strides through the valley of the sun. No response. This was midday type of time. So then I called up the trouble number for the Schenectady IPC and said, that is time sharing running? Yeah. Are you sure about that? You go and look. Oh, fine. Came back. Fine. Okay. Well, would you tell me what's coming out on the 235 typewriter? He goes away. It's a silence for 10 minutes. The phone gets put back. Similar thing happens when I call up the New York center. So I call up Phoenix and I get a very agitated person on the phone. Who's this? Who's this? And I say, the Jolly Green Giant.
November.
In a half an hour, we had a phone call back saying, yeah, you and the other fellow did it. All expenses to Phoenix. Show us how you did it. We'll give you the Fortran compiler.
In November 1964, Phoenix, my manager told me I had 90 days to completely turn off the Dartmouth experiment. 87 days later, Dan Scott and I had gotten paying customers on the system. And on Sunday at 5 o'clock, I became unemployed.
It seems, I recall that Phoenix suffered a number of minor casualties like that, I guess you'd call it. In the ALGOL compiler, for a long time, there was a way of making fixes online. We put it in a way that made it very hard for the students to find out how to do it, because using that, of course, you remember the thing about stuffing jumps to the bootstrap program. Well, you could have done that yourself, and all of those variations could have been done. It's very odd. I never did figure out why no student ever found that one. But it was very useful to us when we wanted to irritate the people in Phoenix who occasionally had irritated us back. And we could call them up over the telephone lines that they so kindly were providing us with. And we could kill their system in a way that would cause the typewriter to type out almost anything we like. And we would sit there, usually in the middle of the night, and compose little memos to them in their error messages, I guess you'd call it. But that was kind of a favorite pastime of ours in various different ways. During the early days, the computer center was used a lot for strict batch processing, card-oriented stuff, no time sharing going on, so the DataNet 30 wasn't being used at all. And Ron, you wrote a program in the DataNet 30 that would just sit there and waste time and display something pretty in the lights, until somebody went in there and modified it to use that feature of writing anything it liked into the 235. Only in this case, if I remember right, it waited 15 minutes to do it, and then what it wrote was in wrong parity, so the 235 came to a screeching halt.
Well, actually, it waited 10 minutes because it was called 10 Minutes to Live, and it was written especially for a particular faculty member at the engineering school who was not well enjoyed by the students, and he would come in and hog the machine during our development time for running his background freestanding Fortran programs. And in order to discourage him from getting too much work done, we set about writing this program. And he had seen the lights flash on a number of occasions before, never paid any attention to them. And in this particular case, we set the thing going, and he didn't pay any attention, and we went out and left. Came back a while later, and he was still trying to find out why he couldn't start it from scratch or do anything on 235. It was absolutely dead. Another little thing you saw before about being evasive and jumping around and watching when the bootstrap was catching up to you. There was another trick that got pulled once that was similar, but even worse. Rather than sitting there and trying to evade this captor that's trying to catch you, you can play another game. You can listen to all the requests in the mailbox and put back all the proper responses, but never do anything about them. Just make believe you're doing the things. And then you can use all the rest of your time, it's interrupt driven, use all the rest of your time to do whatever you want. Meanwhile, the Data in 30 would think that it was sharing time for everybody in the world, but it really, it would never get upset because you kept responding. It would never try to wipe you out.
I remember one of the first things I ever did when I learned something about the D30, I put a brand new command in. They had old, new, run, save. I put a command in called zip. Zip looked just like any other illegal command. It typed what question mark, just like an illegal command did. But it guaranteed that the next person swapped in was you. It was extremely handy for systems programmers. They finally had to disable it. Two systems programmers who really wanted to get something done would just alternate. One would come in, next one would come in, and no one else would get anything done. The system had something. If you did nothing for 10 minutes, they disconnected you, assuming you were a dead terminal. Some poor person was running a relatively short program, and after 10 minutes of waiting for something to happen, you got disconnected because they never even swapped in for 10 straight minutes.
There were actually other ways of causing the same thing. One problem was once we had terminals upstairs, we still had a couple downstairs in the machine room, and those were the ones that the programmers normally used. And I know one fellow who is here, who one day was working, just doing some routine type work on the control teletype, and it got to be time for him to rush off to class. And sort of a hurry and didn't think too much, and instead of typing goo or bye to sign off, he typed off, which leaves the control line working just fine, but no other users get anywhere. Kevin, Steve Brown suggested you should tell the Dartmouth ALGOL story.
Oh, yeah.
All right. Early on.
Making requests.
Oh, that's a whole other story. The Dartmouth, well, the compiler for ALGOL, at the top of its output, no matter what happened when you tried to do a run, would type out just the phrase Dartmouth ALGOL, and then would follow either output or program listing or whatever it was that you'd asked for. Yes, particularly in the early days when all this thinking went on, and somewhere along the line, Phoenix, the GE people in Phoenix asked for our whole system, including ALGOL. And we were worried at the time because we didn't like some of the ways that Phoenix people have been acting like they were going to take the system and make it theirs. We did, in fact, take things very personally. This was our system, and it was not about to become their system suddenly. So in the ALGOL compiler, we went to considerable pains to hide the code without the phrase Dartmouth ALGOL. It didn't appear as text anywhere in the compiler. It was in there all right, but it didn't appear as text. And what's more, the stuff that put it out was disguised in the middle of the middle of several places. In one place was actually in the middle of the routine that loaded it onto the disk, modified everything to link it all together. And the routines that actually put it out looked like they were, I think the comment on them said something about padding the symbol seller. So that anybody looking at the listing couldn't possibly discover what was doing all that. And sure enough, about, I think, a month and a half after the first version of ALGOL got out there, we got a call asking, how in the world is that thing put out? Sure enough, they had wanted to take it out.
It's interesting to look at the original manuals that came out. They came up with their original manuals for the 265 system, and there was the General Electric Basic Manual and the Dartmouth ALGOL Manual. They never found out how to keep ALGOL like the Dartmouth ALGOL.
The manual titles are an even more interesting progression because the original ones for the commercial system were GE stroke Dartmouth Basic. Then it went, or Dartmouth stroke GE Basic. Then it went GE stroke Dartmouth. Then they dropped the Dartmouth off.
All of that took place after mid-February 1965.
The keeping of Dartmouth ALGOL secret was even from the person who followed Mr. O'Gorman, Bob Lumsden, who isn't here. He had no idea how Dartmouth ALGOL was being put out. He said, gee, here's a subroutine that the ALGOL compiler doesn't need. And he erased it. And then he loaded up this new ALGOL system and it typed out exclamation point, question mark, outside. And now I know why it's necessary. But the following student had no idea where the word Dartmouth ALGOL came out till he stumbled on it by accident.
I'd like to tell a story about some of these early days. You can sort of tell that we were sort of misguided high school kids going to college. Oh yes. And one of the games we would play would be to go downstairs and there was a control teletype. They could talk to any other teletype. And one of the features of this was that the other person didn't know that this had happened to him. So that suddenly he was talking to you rather than whatever he thought was going on. And you generally go down there just before a football game or something when everybody was up there trying to impress their dates with the computer. And you'd take control of the computer, and so they'd be talking to you. You got some very interesting conversations. One I remember was, one of the games was to type as fast as possible, so they thought it was a computer rather than some stupid person downstairs. And somebody realized there's a little more intelligence in this terminal than they thought, and started asking questions. And one of the questions they asked, what's the score of the football game going to be? So I think, well, I typed something very fast, 14-7, and I was right. And it was a big argument after the game up in that room. Like, yeah, but the computer can predict these things. No, I never did find out who it was. I just heard the reports of it.
I'm still working on doing incidentally, while Len Smith and Sydney are exchanging here, I don't think Len went into too great detail when he was talking about all the things that you can learn about the system by typing explain. There are some things I chose not to explain, but there are others that I believe if you type explain JGK, you still get a portrait. However, if you type explain Sydney, it still says there is no explanation for Sydney.
I remember the time, I think it was in the day where we're in the computer room in the basement there. And this official looking fellow, I guess he was a fireman, came in. He had a radio in his hand. And he was very upset because he said that he'd been detecting unauthorized emissions on the official fire department channel, and he'd been going all over town trying to figure out who was putting out these signals, and he traced it to the computer room there. Well, lo and behold, he was right, of course. It was a 1 microsecond machine, so I think it had a strong signal in the megacycle wavelength or something of that sort. Well, we didn't really know what to do, so we struck a compromise, and that is that if there ever was a fire, and they had to use their emergency radio, they would call us up and tell us to turn off the computer, and we would do it.
We discovered we could use that noise on an ordinary radio to make music. It is sort of crude. Put a little radio by the console, take control of the time-sharing system. We never felt too much about users then. We had something to do. The users, you'd always go up there and there'd be a puzzled look, you know. Gave one a great sense of power, but looking back on it, it probably wasn't too mature.
Well, I think one thing we haven't talked about yet is the effect users had on the development of the system. And I would like to tell one story. When the system was first up on the air, my son was in grade school, fairly early grade, and therefore I was held up for giving a tour to his class to the computing center. And I think you saw some of the pictures. We were, of course, in the oldest building, and the equipment was done in the basement, but the teletypes were upstairs. And I gave a demonstration, a Model 33 teletype, and I did a couple of programs written that grade school kids would enjoy. And someday could sit down and type things in, and it was very exciting. And then as a real treat, I took them downstairs to show them the computer. And my son's teacher called me up the next day and said, you might like to know what happened in show and tell. You know, they had to go next day and explain what their field trip was about. And she said it was really amazing. All the kids spoke up. They all enjoyed it very much. Then she asked, well, did you have any questions that didn't get answered? And one young lady raised her hand and said, well, I understood perfectly everything Mr. Kemeny did on the computer. And she summarized some of the things, but then he took us downstairs into the basement and showed us a great big box that looked like a refrigerator, and I never did find out what it was. So I mentioned that as an example of user influencing the system because for a while I told that purely as a joke, but it eventually changed my mind totally as to what a computer is once you go into a time-sharing system. I mean, ask yourself what you mean by a telephone.
It's
Okay.
amazing that inconsistency carried on to Dartmouth students. I mean, they were given this basic manual that says you sit down at the terminal and push the button and log in. We had some poor guy who came to College Hall where all the terminals were, and the computer had a disk crash, was down, big sign, computer doesn't work today. Guy went over to another classroom building, Filthy Hall, and sat down and says, how come this computer over here doesn't work? Everyone was convinced there's little gray boxes, and each gray box is a computer. The basic manual gave students originally that opinion. I think part of it's done by keeping the computer in the basement of College Hall. Nowadays, with the computer behind the big glass windows, you can see when you get to the terminal room. Hopefully, Dartmouth students still don't know the terminal's on a computer.
Yep.
Do they still ask for the big computer when they want the 35 teletype that has the paper tape instead of the little 35 that the little computer, which is the 35 without the paper tape?
So, the way nobody else went. Why didn't you say the Well,
Thank you. I just had a very nice compliment paid that I've never been safe in my life. I've never played safe in my life. But I think that has to be answered in two parts. I think we have to answer it both for time sharing and for basic. And the answer is much simpler on time sharing because it simply was totally impossible to teach hundreds of students each year on the batch processing system. I used to tell, and I did actually say this to the Board of Trustees when we made a presentation, that I had seen at the RAND Corporation, where I was a consultant, some of the world's most famous scientists stand in line for an hour to get 5 seconds of computing time. So I could see such famous scientists putting up with it. Dartmouth undergraduates would never put up with that kind of system. So the decision to time sharing was a very hard one, but was totally unavoidable. And I don't think we ever had any doubt we had to go to time sharing to do that, Tom, did we? Absolutely. So that we never had doubt about. On basic, it was a quite different kind of question, and maybe this gives me a chance to add just one thing to the very good presentation on basic that was done. We certainly never conceived of it as getting to be as large a language as it has gotten to be, but we did think of it from the beginning as being useful for more than just beginners. But the key concept we had in mind was that the language ought to be built in such a way that it's sort of in levels, and that the beginning user learns as little as possible, and then you learn the next level and the next level beyond that. And one of the interesting things as a result of that is that the programs that ran in 1964 on the system still run on the system today. The answers are not always the same because I wrote the first compiler and there were some errors in it. But basically, the very same programs still run. I mean, I'm sure that program I wrote for generating prime numbers by the SID method would still run today, and there's nothing in it that has been changed since that time. And so we really philosophically believe that there ought to be a different kind of computer language. I mean, Fortran was an enormous advance when it first came. I mean, a user-oriented language is the big breakthrough. But that does not mean that the first one is good. And I'm afraid Fortran was written with advanced users in mind. And we felt very much that there had to be a system written which gave first priority to the inexperienced user, but also could accommodate the more advanced user.
At the same time that BASIC came into existence, IBM had a system called QuickTran, which was a Fortran in a time-sharing environment. And a little over a year later, John Geechee and I, in a consulting company, wrote a memo into IBM that permanently put QuickTran out of business by essentially comparing the two systems in terms of ease of learning, ease of remembering, and growth complexity. And at that point, IBM decided to standardize into the 360, what I call 360 data.
Yeah, one very embarrassing afternoon, I suspect, for IBM was when they decided to demonstrate QuickTran at Dartmouth. So they put the terminal up in our teletype room, which was filled with students of varying sizes, all working at terminals, getting their work done. And then there was this QuickTran terminal. And I was sort of embarrassed too because I had previously worked for IBM and happened to know some of the people who were there. And I'm sure that they just, at that point, were not expecting or prepared to demonstrate their time-sharing system to people, first of all, students and blue jeans and stuff, who had themselves written a time-sharing system that was being actively used all around them. It was really rather awkward. Remember it?
Did anybody ever, I mean, was there...
They spent 2 hours, and I don't think they got the little program running.
Well, I hate to call things to a close here, because I think there are probably many other things that people are recalling, but I'm getting some signals from some very important people in the audience. Carry on? All right.
I wondered how,
Yeah.
I was just thinking, since such a beautiful case, I hadn't seen the slideshow, and I thought it was beautifully done. And as you really got across the idea of a system whose primary design was to make it as simple and easy to use as possible. And we mentioned it in terms of basic, of course, equally important, just the very simple commands like new, old, save, run. Were really, at that time, a major breakthrough in computing. One of the things that disturbs me is this is now 10 years later. When will other systems learn that this is a good philosophy for writing computers? I happened to visit another academic institution, which I won't identify, but I'm very fond of. And they have an operating system in there. And in introducing me, they said, here is the college president who speaks BASIC, and then said, instead of speaking, and mentioned the name of that particular operating system, at which point the entire student body started laughing uproariously. It's a joke that had to be explained to me afterwards because I didn't know what the reference was. But I just don't understand why this so. I'm not saying that what we did couldn't be done much better today. I'm sure somebody will do it much, much better. But why is the philosophy of doing things so it's easy to use for the user so terribly hard to get across to other systems? That's something I just don't understand.
I've noticed that the way the BASIC manual was written, most people are convinced that new, old, save, run are part of the BASIC compiler. A lot of other time-sharing systems, you type run BASIC and it comes back new or old dash dash. We at Dartmouth always got a big kick. That was separate from BASIC. That was the operating system. I mean, that's what made you use the same commands for ALGOL, PSAP, any of the other languages you wanted. And it's a real shame that other people thought that run, new, old, and save were part of BASIC, not part of something above BASIC, which you would use other languages.
But I think you're quite right on that, Steve. On the other hand, that was part of the design that the user didn't have to know there was such a thing as an operating system.
I noticed that when General Electric came out, they came out with a separate command system manual, separate from the BASIC manual, and you now have to wade through two manuals to learn the system. I think that's a very good idea, putting it in one manual. But a lot of people, computer science professionals, misunderstood it. They started to think that all these things, the edit system, the command system, and BASIC, they thought it was all one thing. It was all written up in one manual. And whenever you have three separate things, you're supposed to put it in three separate manuals, not one.
One of my recollections from that period of time was that although the time-sharing system at Dartmouth had its genesis in the desire to make computing an integral part of the educational process at Dartmouth, not all of the faculty was swayed over to the use of computers that quickly, and for some years after the system became operational, there was a certain level of hostility among certain factions of the faculty. I recall particularly the fact that I guess our senior year, Kevin and I worked up the nerve to take a course in music composition. It's very listening to Professor Appleton today. It was just very encouraging to see that the difference in attitude that existed in the music department then and now. I recall at the time I guess we were learning composition in the form of chorales, and we were studying Bach, and we had exercises in composition in that form. And one of our big problems, of course, was that we didn't have a synthesizer, and we didn't play the piano, and we had a very difficult time listening to the thing we composed. But after we worked very hard to put together a composition as a homework assignment, and to either two-finger pick it on the piano or to find a music major who would play it for us, and turned it in for grading, instead of coming back with comments about how aesthetically pleasing it was, the corrections that were made by the teacher were always nitpicking about technicalities. You know, we had a parallel fifth there and a triad someplace else, and I'm probably belying how much I forgot about the harmony course. But Kevin and I were kind of discouraged by this, because we went into it not as purely a technical endeavor, but to express a little creativity. So we decided that we'd solve that problem by simply writing a computer program that would check all our compositions for technical errors before we handed them in. And so after we composed something and were fairly satisfied with the way it sounded, we'd type them into the computer and get a list of diagnostics, just as if it was a program. And if there were any technical errors, we would correct them, so that it was assured that everything we turned in was technically perfect. It may have sounded terrible, but it was technically immaculate. This puzzled the professor for some length of time, and when he finally discovered what was going on, I think he almost ejected us from the class. By the end of the trimester, we had swayed him over to our way of thinking, and he was starting to think about the use of a computer. But students who were motivated to make early use of the computer in doing their homework and so on often met with this kind of resistance in the early days. Now, of course, the system is just tremendously well accepted throughout the university.
I'd like to say something about the reliability that we mentioned earlier. I do remember one occasion on which an installation of a new monitor wasn't as successful as it usually was. In fact, there was a rather blatant flaw that whenever one of the students typed test, which is a way of determining whether a basic program did its job, it would crash not the 235, but the DataNet 30, which was a very unusual kind of software failure in those days. But it was also disastrous in the sense that it was almost impossible at that point to recover. We had live users all over outside trying to use the system. And once it failed, went down, it would come back up by itself. And before we could fix it, it would fail again because somebody else typed test. And fixing it meant putting an octal patch into DataNet 30 core from the control terminal, but it was just failing too fast to do it. At one point, I was about ready to tear my hair out when I finally found out what was happening. At that time, it was Professor Kemeny, came storming in and said, "Why doesn't this system work? Every time I type test, it seems to fail." And I remember going off the deep end, and my response was, well, if people would stop typing test for a while, I could fix it so that it would work.
It is interesting. Like I was a freshman when Mike was a senior. By the time I was a sophomore taking a sophomore physics lab, I got very ambitious and did one of my physics lab on the computer, and the grad student with the lab assistant says, "Computer, you know, you're supposed to do this by hand. I don't want to see it." By complaining to the lecturer, he immediately went back to the grad student and said, "You encourage kids to use the computer. If you don't know how to use the computer, they give a 2-hour course for faculty members. You must take it, and you must encourage people to use the computer." In just a very short period of time, you know, a good deal of the faculty members were going out of their way. If you wanted to use the computer something extra, as you know, an extra credit thing, they preferred you to do it that way.
Along the line of physics, in my freshman year, first term or second term, before the time-sharing system was available, the only computing facility we had on campus that was available was the 1620 at the Tuck School. And I was taking a sophomore physics course, and since I hadn't been through all of the rigors of labs as in the freshman classes, I had skipped the courses. I really didn't know what was expected in terms of labs. Well, there was one particular experiment where we were measuring the charge to mass ratio of an electron, and I was the only person left in the class that didn't have a lab partner. And I decided that the way to get good results was to take a large number of measurements. I took about 25 measurements, and I analyzed the data on the 1620. And the only reason I got a B on the lab instead of an A, I remember, was that the guy who graded it said that I didn't show my work.
Well, on that note, I'd like to turn the meeting over to a couple of very fine people from APIP who have a job to perform, I guess. Just one? Okay. I recognize that good-looking young man over there. That's George Glazer, president of APIP. George.
You're like a heel. You're obviously having such a good time.
And I certainly don't want to break up a session like this because they're very rare and it's nice to watch it going on. I also can do nothing but applaud your pleas for simplicity, and certainly in the interest of the user. But it is my very great pleasure at this point to present on behalf of AFIPS to both Drs. Kemeny and Dr. Kurtz an award to tell them just in a little bit how we feel about the contribution that they've made. And if I may, I'll read to you a citation. The citations are identical, but we did invest in 2 plaques. It reads as follows. American Federation of Information Processing Societies, Inc. commends Dr. John G. Kemeny, President, Dartmouth College, in recognition of his pioneering efforts in the development of time-sharing and his co-authorship of the computer language BASIC, Pioneers Day, May 8, 1974, National Computer Conference. Dr. Kemeny. Thank you.
I don't have an acceptance speech, but I do have an announcement from Ted Bellin that to the effect that those of you who are counting on getting bus service tonight, there will be bus service at 7 p.m. and also after the play Oklahoma gets out.
Tom, could I give an acceptance speech on behalf of both of us then?
Yes.
It is customary in accepting Academy Awards to mention your mother, your father, your music teacher, and your coach, and everyone else who really deserve the award. And I'm going to follow that precedent by saying that for both Tom and me, this award would not exist except for the work done by a number of undergraduate students at Dartmouth College, one graduate student, many of whom are sitting right here, and some of whom are not here. And therefore, I think we deserve each deserve about half of our own award, and the other half will be divided equally amongst the other students who did all the work.
I guess that concludes the session. Thank you very, very much.